we are solving the third problem in which we had 100 students that were solving 3 problems, and overall they got 200 solutions. Right. So we are asked to prove there were 2 problems solved by at least 34 participants. I thought about this way. If there are three problems and 100 students, they submitted 300 answers, right? And 200 were correct, and 100 were wrong, right? So from here, if there were 200 solutions, 200 correct solutions, we can say what?
So that means that there must be one problem that has at most 66. Correct. Like the hardest one.
Yeah, there is one problem with at most 66 solutions, right? So the other 2 were easier problems, right?
So the other 2 have at least 134 solutions that combine.
And 164 solutions, right?
At least 134.
At least 134.
So which means they were solved by at least 34 participants, right?
Together.
So which means there exist 34 participants solving both of them.
That's the easiest way.
So it's a straightforward logic that leads us to our solution.
Right, if you consider what you were talking about earlier, you think about the wrong answers, then how do you modify this?
If you think about wrong answers, then
You can use a red marker to change your argument almost a similar way.
so there is one problem with
At least
34 wrong.
34 wrong solutions. It means that there were 2 other problems.
At most.
Sixty-six.
Solutions.
66 wrong.
Wrong solutions. Which leads us that these 2 problems were solved again, at least by 34 participants. Yeah. So this is just solving it straight. The other way to solve it is to draw diagrams, right? To visualize the problem.
Right. This problem is you try to find out which problem could give you most trouble. Because you want to find the people solving 2 problems, right? So those 2 problems should be the so-called easy problems. More people are solving it. So you should take the hard one out, right? So that's the idea, right? A problem with at most 66 solutions, or equivalent that problem with at least a lot of wrong solutions, right?
For the second solution, we will draw a diagram. And what's the best way to represent this problem is to draw a Venn diagram. In our case, the Venn diagram will have 3 problems represented as 3 circles. So this will be problem 1 solved by participants. This is problem 2. This is problem 3. And Venn diagrams makes a partition of each of these sets, right? So we can mark each of these partitions separately. So let's say S1 will be people that solve only problem 1, S2 will be people only solve number 2. This is S3. So this will be S1 and 2 that solve both of 1 and 2. And let's say S will be people that solve all of them.
S1, 2, 3.
S1 to 3.
And there's people who solve nothing.
That can be yes.
S0 here.
Just S it is.
S0.
Oh, sure, yeah, S0.
Okay.
Yeah, so this is our set. This is our Venn diagram. So what do we know from the conditions?
So we know the sum of everything inside. the
It's
circles.
200.
It's 200, yeah. So it's S1 plus S12 plus
Oh,
S2 plus.
that's a number of students.
No,
right?
this is number of students, right?
Yeah, so if you add all
Oh,
in,
yeah,
it's
sorry.
100. But if you double count S1 to S1 to S2, 3, and triple count S1 to 3, you get 200.
Yeah, this is adding students,
Yes.
right?
Then we do S1 plus S2 plus S3 plus 2S12. It's 2S13 plus.
Now we count how many solutions are there, right? So these are people solve only 1, 2, and these are 3 problems. 2S1, 2,
Yes.
and S0 is times 0, no solution. So what do we actually want to prove? We want to prove that there were 2 problems solved by at least 34 people. So we want to prove one of such regions contains 34 students, right?
So basically, we don't really care about S1, S2, and S3, so why don't we just try to subtract it out?
So if we subtract, we get what? S1, 2 plus S2, 3, S1, 3.
Because 2 S1 to 3 minus
Yeah,
S0
don't forget about this.
equals
So that's 100.
which is at least 100,
Right.
because we don't, because
So now we should assume S0 is 0. We want to prove something is more, right?
Yeah.
Right?
We can just write that.
We can just write this as greater or equal to 100, right?
And since we're looking at those 3 regions, which is not just S12, S13, and S23, but it also includes S123, we can group them together and then add an extra.
So we should,
this.
the 3 sums we want to get is S12 plus S123, right?
Yeah. And then there are 2 others like that. And if we add all 3, we're going to get at least 100.
If we add all 3,
It's going to be at least that one, which is at least 100.
Their sum is at least 100, right?
right, because actually we have 3 of S123,
Yeah.
right?
So it means one of them, the biggest one, as we proved before,
More than the average, which is 34, right?
so this is in, yeah, this is the way we conclude.
as we discussed before, this only works when we have 3 problems. If we have 4 problems, we said we don't have a really good Venn diagram,
Right.
Yeah, unless we use the ellipses.
which is hard to draw, so